Hello guys, welcome back. You can remember in previous video, I told you about that today. In this video, I'm going to teach you non-linear data structures, right? So there are two types of non-linear data structures. The first one is trees, and other one is graphs. So in this video, I'm going to teach you about what is trees, right? So before moving to trees. Now, what is nonlinear data structures, right? The nonlinear data structures is not in a sequential order, right? It has multiple levels, and the data is in a hierarchy, right? What is meant by hierarchy? Hierarchy means think that this is a CEO of a company. This is a dean. This is a lecturer, right? This is the hierarchy of and remember the data is flowing top to bottom, right? This is A, this is B, right? A to B. You don't go from B to A, right? Always you are going top to bottom. So what is meant by a tree? Tree is collection of node, right? This is a node. This is a node. Collection of nodes which link together to represent a hierarchy. Right? Simply, this is a tree. Collection of nodes which link together to represent a hierarchy. Right? This is the simple meaning of a tree. And remember, always these are going unidirectional, right? I previously told you that top to bottom, unidirectional, only one direction, A to B, right? Unidirectional. Here, A to B. And so in a tree there are so many stuffs. That means leaf node, non-leaf node, edge, path, likewise. So we will learn one by one. So first, what is meant by a leaf node? Right? Leaf node. A leaf node is the node that is not that does not consist child, no child here, right? This is a leaf node, right? You can see in this node there are no children, right? This is leaf. And also I will tell you about another two things, that is immediate predecessor and immediate successor. Immediate predecessor is the parent node, and the immediate successor is child node. This is a parent node and this is a child node. This is, and B is a parent node and this is a child node, right? That is mean by immediate predecessor and immediate successor, right? So now, what are non-leaf nodes? Non-leaf node is just internal nodes. Right? B, C, D, those things are non-leaf nodes, right? Then we will move upon to edge, right? So what is mean by edge? Edge means the link between two nodes, right? This is an edge. Link between, there are two nodes and this is the link. That is mean by edge. And what is mean by a path? Path means the sequence of consecutive edges from source node to destination, right? Sequence of consecutive edges from source node to destination. This is the path. This is suppose A and I. This is the path, right? And what is meant by an ancestor? Next we will move about the ancestor. Ancestor is that any predecessor node. Predecessor node, what is predecessor? It is a parent, right? Any predecessor node of the path from root to that node. From root to that node, right? For an example, what is the predecessor of L, right? This is L, right? What is the predecessor of L? What is the definition? Any predecessor node of the path from root to that node. That means from root to L, this node. So A, C, G, right? A, C, G. A, C, G is the answer, right? Right? Next, what is the descendant? Descendant is any successor. That means immediate successor is child. Any successor node on the path from that node to leaf node. From that node to leaf node, right? So think we are taking C, right? C means from that node to leaf node. When we take C from here to the leaf node, G, L, M, right? This is the descendant. And if we take B, sorry, if we take B, E, I, J, K, and this is also a leaf node F, likewise. Okay. Now we learned about 6 things, and there are some more to learn. Next, we'll move on with the subtree, right? This is a whole tree, entire tree. This can be taken as an entire tree, and a subtree is part of this, right? This is a subtree. Right? This is also a subtree. Okay, guys. Now next we will move on with the, and I talked about in subtree. Subtree means these are the subtrees, and subtree is not with all its descendants, right? And when we move to siblings, what is meant by siblings? Siblings is the children of same parent. That is meant by a sibling, right? So in here, if we take B, the siblings are E and F. So E and F belongs to same parent, right? B. That is meant by a sibling. Next, when we move to degree, right? Degree means the number of children of node, right? Now, if we take, and before that, remember the degree of leaf node is 0. Degree of leaf node is 0, and when we take degree of A, right? Degree means the number of children of the node, right? If we take degree of A has only 3 children. A has B, C, and D, right? That is the degree of A. You can see what is the degree of J. You can see that J is a leaf node. So I told you that the degree of a leaf node is equal to 0. So this is 0, right? Next, we are moving to maximum degree, right? So in this thing, maximum degree is 3. So why? Because every parent has only three children. There are no parent that has more than 3. E has 3 children, A has 3 children, likewise, right? The maximum degree is 3. No node has about 3 children, right? Next, we are moving to depth. Depth of a node. Depth of a node is length of the path from root to that node, right? Length of the path from root to that node, right? What is the depth of J, right? From root to that node, right? Root is A and we are taking J here, right? 1, 2, 3, right? 1, 2, 3. 3 edges, right? It is mean by the depth of the node, right? Next, we will move to height of a node, right? Height of a node is number of edges in longest path from that node to leaf node, from that node, that particular node to leaf node, right? We are taking the longest path here. So take B, right? What is the height of B? 1, 2, right? Height of B is 2. So we can't take, so you can see that F is also a leaf node, but we can't take F. Why? Because this is not the longest path. We have another longest path, 1, 2. What is the height of L, right? Sorry, what is the height of G? 1, right? Again, I will tell you what is the height of B from this node to the leaf node. 1, 2, and we are taking the longest path, right? What is the height of C? 1, 2, 1, 2, right? So it is. So those are the things that I'm going to describe you to get some knowledge about what is meant by trees. So the trees have binary trees, and the binary trees consist of complete binary, full binary, those things. So next we will move upon with binary trees. Okay guys, now we will move with the binary trees, right? What is meant by a binary tree? In binary tree, it can have at most 2 children, right? Only they are at most, right? Tree can have only 2 children, at most 2 children. It is meant by a binary tree, right? Okay. 0, 1, 2. Only these things, right? So this is binary, right? This is also a binary, right? Is this a binary tree? Yes. This is a root node. It can. It's a binary tree, right? Is this a binary tree? Yes. This is also binary tree, right? Is this a binary tree? No. There are 3. This is not a binary tree, right? And this is the logical representation of the binary tree, right? You can see this is the left subtree and this is the right subtree, right? So here there are A, B, C, D, E, F, right? In A there is a left subtree B, right? And to B there are left subtree and a right subtree, that is D and E. And in C there is a right subtree, in A there is a right subtree as C, right? And in C there is no left subtree, there is a right subtree for F. And these have no children. These are leaf nodes. Therefore, these are empty. Right? So, there are the properties of these are I just explain you two properties. There are more. First one is at most two children must be there in a binary tree, and the maximum number of nodes is possible to at any level I. I mean the height, right? So suppose any levels, 0th level, 1st level, and 2nd level, right? So now there are 3 levels here, right? 2 to the power 0, 1 and 2. 2 to the power 0 means 1. 2 to the power 1 is 2 and 2 to the power 2 means 4, right? This is the maximum number of nodes possible at any level. We are just putting I, 2 to the power I, right? I forgot to tell you about we use trees in real world to implement file systems, right? To implement file systems we use trees. So there are many types of binary trees. Though I will teach you some of them. There are full binary tree, complete binary tree, perfect binary tree, and there are some more. So now I will talk you about full binary tree and complete binary tree, right? So what is mean by a full binary tree, right? Full binary tree. A full binary tree is each node has exactly two children except leaf node, right? Except leaf node, right? 0 or 2 children. This is a must, right? There can be 0 or 2, no more than this thing, okay? 1 also is incorrect, right? This is the full binary tree. And see, I think the condition is satisfied, right? The condition is satisfied. Exactly two children, right? Exactly two children, and it can be possible there is no children, 0 or 2, right? So is this a binary, full binary tree? No, because this contains one. This is wrong, right? This is not a full binary tree. So this is the simple idea of full binary. And now we will move on with the complete binary. Right? Complete binary. So complete binary tree means all levels are filled except the last level, right? All levels are filled except last level. And remember, in when we are taking the last level by leftmost, we have to fill the nodes in leftmost direction, right? I will show you it in an example, right? This is a complete binary, right? You can see all levels are filled except the last leaf nodes. I told you that there's a condition, it must be filled by leftmost side, right? So this node is in left mode. Now, is this a complete binary tree? No, because this is empty, right? Is this a complete binary tree? Yes, it is also a complete binary, right? And is this a complete binary tree? No, right? So I suppose that you will get a better understanding about trees. So I talk about what is meant by a tree, what is the logical representation, and what are the types of binary tree, that means complete, full binary tree, and I told you about some properties of binary tree, what is leaf node, what is non-leaf node, what is path, what is edges. So I hope that you will gain some better knowledge about trees. So in next video, I will come up with a sorting video, right? Till then, goodbye guys.